Today in Algebra 2, we're going to look at section 5.5, which are function operations. Our essential question for this section is how can you combine, multiply, divide, and compose functions, and how do you find the domain of the resulting function? After this lesson, you should be able to perform operations on functions and answer real-world questions. All right, so let's start out with this scenario. So we know in business, the term profit is used to describe the difference between the money the business earns, which is known as revenue, and the money the business spends, which is known as cost. So part A, we have Grooming USA charges $25 for every pet that is groomed. Let X represent the number of pets groomed in a month. Define a revenue function for the business. So since it's revenue, we're just going to call it R. So we could say R of X is equal to 25x, because for every pet they groom, they get $25. Revenue is how much money they earn, so 25 times x. B, materials and labor for each pet groomed cost $15. The business also has fixed costs of $1,000 each month. Define a cost function for this business. So we're going to call this C of x. So this is how much it costs them to do business every month. So for every pet they groom, it costs $15 plus an additional $1,000 every month. So we would say 15x plus 1,000. So then it says, last month, Grooming USA groomed 95 pets. Did they earn a profit? Well, we can see what their revenue was. So we're going to take R of X, the revenue, 25 times, we're going to plug 95 in for X because that's how many pets they groom. So we would get a revenue of $2,375. We can check their cost. So the cost would be 15 times 95 plus 1,000. So when we work all of that out, we get 2,425. So remember that profit is equal to revenue minus cost. So our profit would equal $2,375 minus 2,425. So here my profit is equal to negative 50. So no, they did not earn a profit. No, they lost $50. So if in a month they only groom 95 pets, they do not make any money, they actually lose $50. Okay? So now we're going to look at adding and subtracting functions. So f plus g of x, okay, is equal to f of x plus g of x. F minus g of x equals f of x minus g of x. Then it tells us that the domain of f is a real number, the domain of g is a real number, so then the domain of f plus g and f minus g would also be a real number. So we're going to identify the rules for the following and find the domain. So if f of x equals 3x plus 4 and g of x equals x squared minus 5x plus 2. So first let's just look at what is the domain of each of these. Okay? So my domain of f. So 3x plus 4, is there any number that I cannot plug in for x and get an answer back? Okay, 3x plus 4, that's a straight line, right? I can plug any number in I want, so that is going to be all real numbers. So now let's look at the domain of g. X squared minus 5x plus 2, that's a parabola. I can plug in any number I want to for a parabola. So again, all real numbers. So now if we do f plus g of x, so f plus g of x is going to equal, so my f, 3x plus 4, and then I'm just going to add to it g, x squared minus 5x plus 2. So f plus g of x, I want to combine like terms now and put it in standard form. So I have x squared, a 3x and a negative 5x give me minus 2x, 4 plus 2 plus 6. So there's f plus g of x. I can find the domain of f plus g. Again, it's another parabola, all real numbers. Okay. So now let's find f minus g of x. So again, I start out with f, 3x plus 4, minus, I'm subtracting all of g, so I'm going to put all of g in parentheses, x squared minus 5x plus 2. I'm going to go ahead and distribute my negative, my subtraction sign in my parentheses. So I get minus x squared plus 5x minus 2. And so again, now I want to combine like terms and put in standard form. So I've got negative x squared plus 8x plus 2. And then the domain of f minus g, again, it's a parabola. I could put any number I want to in for x. Okay, so let's practice that again. So number 2, f of x equals 2x squared plus 7x minus 1, g of x 3 minus 2x. Again, my domain of f is all reals because it's a parabola. My domain of g, another line, all reals. So if I do f plus g of x, 2x squared plus 7x minus 1 plus 3 minus 2x. So plus g of x, combine like terms, so I have 2x squared plus 5x plus 2. I can look at the domain of this. It's a parabola. I can plug any number I want to. So now let's do f minus g of x. So again, I start out with f, 2x squared plus 7x minus 1 minus all of g, so I put g in parentheses again. Distribute that subtraction sign. So I get minus 3 plus 2x. And combine like terms, put in standard form. So I have 2x squared plus 9x minus 4. The domain, again, this is a parabola. I can put any number I want to in for that. All right, next page, we're going to look at multiplying functions. So it tells me that the demand D in units sold for a company's new brand of cell phone at price X in dollars is D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? So first, let's talk about what our demand is and what our domain is. So they give me the demand, D of X equals 5,000 minus 10X. So let's talk about the domain of the demand. Right? Demand is how much they need, right? Well, we know that that would have to be greater than or equal to 0, right? Because they're not going to have a demand of negative 5 units. So I'm going to take this 5,000 minus 10x and say that has to be greater than or equal to 0. So when I solve that, if I move 5,000 over, so then I get negative 10x has to be greater than or equal to negative 5,000. Divide by negative 10, so I get x, I divided by negative. Okay, so since we divided by a negative number, remember that rule that says if you divide by a negative, then you have to flip your inequality sign. So this becomes x is less than or equal to 5,000 divided by 10 is 500. So the domain for the demand is x has to be less than or equal to 500. So now let's talk about the price. So the price, I'm going to say P of x is equal to, they tell me that the price is just x. Let's talk about the domain of the price. So the price, how much they're going to sell something for, again, they're not going to just give it away, right? So it has to be at least 0, right? So x would have to be greater than or equal to 0. And they're not going to have a negative price. Our revenue, so we're going to call that R of x. Here they tell me revenue equals price, so P of x, times demand, so times D of x. So I can say R of x is equal to x times 5,000 minus 10x. Distribute, so I get R of x equals 5,000 x minus 10x squared. So that's our formula for revenue. The domain of the revenue will be the intersection of the domain of price and demand. So therefore our domain, so price domain had to be x is greater than or equal to 0. Demand, x had to be less than or equal to 500. So my domain of my revenue is going to be x between 0 and 500. So x would have to be between 0 and 500. Okay. All right, so let's try another one of those. Suppose demand D for company's product at cost X is predicted by the function D of X equals negative 0.25x squared plus 1,000. At the price P that the company can charge for the product is given by P of X equals X plus 16. So now they gave us a price function as well. And the company's revenue function. And we're also going to talk about domain. So let's look at the demand function and talk about what is our domain going to be of the demand. Again, if it's demand, we know it has to be at least 0, right? So we're going to take all of that, negative 0.25x squared plus 1,000. That has to be greater than or equal to 0. So we can solve that. So then I get negative 0.25x squared has to be greater than or equal to negative 1,000. Divide by negative 0.25, so x squared, again, I have to flip my inequality sign. Has to be less than or equal to 4,000. Take the square root of both sides. I only want the positive numbers, so x has to be less than or equal to, the square root of 4,000 is not a nice whole number, so we're going to approximate that. That's about 63.25. So we're going to say that x has to be less than or equal to 63.25 for the demand. The price, P of X equals X plus 16. Again, that's going to have to be bigger than 0. So my domain here, X would have to be greater than or equal to negative 16. Because negative 16 plus 16 gets me 0. So now our revenue, same thing. It's our price times our demand. So X plus 16 times negative 0.25x squared plus 1,000. So we're going to distribute. So then we get negative 0.25x cubed plus 1,000x minus 4x squared plus 16,000. So if I write that in standard form, my revenue is negative 0.25x cubed minus 4x squared plus 1,000x plus 16,000. So there's our revenue function. The domain of the revenue, so we're going to do domain of revenue. Again, it has to be in between the two. It has to be a combination of the two domains of the price and the demand. So here x had to be greater than or equal to negative 16. So we're looking at negative 16. X has to be between negative 16 and 63.25. That's the domain of our revenue function. All right, so next we want to talk about dividing functions, and this is where we will stop for today after we talk about dividing functions. So divide functions, we have f divided by g of x. That's going to equal f of x divided by g of x. And it tells me that the domain of f divided by g is going to be the set of all values for which f, g, and f divided by g are defined. So g could not equal 0. So we will identify the rule and the domain for f divided by g for each pair of functions. Okay? And notice right off the bat, number 1, f of x equals x minus 7. That's a line. I can plug any number I want to in for f. G of x, 2x squared minus 13x minus 7. My domain for g of x is also all real numbers because it's a parabola. So let's see what happens when I do f divided by g of x. So I would take x minus 7 over 2x squared minus 13x minus 7. But remember that we can't leave it like this. We want to completely simplify, which means factor if possible. So if I was going to factor this. 2 times 7, that gets me negative 14x squared. Right? I'm trying to get a negative 13x. So I could do that with a negative 14x and a positive 1x. So I'm going to rewrite this as 2x squared minus 14x plus x minus 7. I just rewrote that negative 13x with the negative 14x plus x. So now I can factor this, pull a 2x out of here, and I get x minus 7. Okay, combine these two. Right, so I'm doing like my grouping, pull a 1 out, and I'm left with x minus 7. So on top, up here, I have x minus 7 over 2x plus 1 and x minus 7, because that's what the bottom factored to. But now I have an x minus 7 on top, x minus 7 on the bottom. They're going to cancel each other out, right? So that leaves me with a 1 over 2x plus 1. So that is what f divided by g of x is equal to. But now I need my domain. So recall back when we were doing rational expressions and we would factor tops and bottoms and then find the domain. Remember, we always found the domain from the original denominator. So my domain, I had to go back before I canceled anything out and say both of these cannot equal 0. So here I get x cannot equal negative 1/2, and here I get x cannot equal 7. So this is my domain, x cannot equal negative 1/2, x cannot equal. So let's do a few more of those to practice the dividing and finding our domain again. So number 2, f of x equals x squared minus 3x minus 18, g of x equals x plus 3. Again, if I want f divided by g of x, so on top I would have x squared minus 3x minus 18 over g x plus 3. I need to factor the top. This one's going to factor nicely. So x and x, what can I multiply together to get negative 18, but add to get negative 3, so that's going to be a negative 6 and a positive 3. X plus 3 is canceled. So f divided by g of x is equal to x minus 6. And now I need my domain. The domain, I go back to the original one before I canceled anything. X plus 3 cannot equal 0. So x cannot equal negative 3. There's our domain. Okay? So again, remember to find the domain from the original before you reduce. Let's do one more for today. F of x equals x minus 3. G of x is x squared minus x minus 6. So f of g of x, x minus 3 over x squared minus x minus 6. The top can't factor. The bottom, we're going to see if we can factor. What can I multiply together to get negative 6, but add to get negative 1? That's going to be a negative 3 and a positive 2. My x minus 3 is cancel. So I'm left with 1 over x plus 2. That's what f divided by g of x is equal to. So now I want my domain. Again, I go back to the original. X minus 3 cannot equal 0. And x plus 2 cannot equal 0. So my domain, x cannot equal 3, and x cannot equal negative 2. Okay. All right, so that's our first day of functions, adding, subtracting, and dividing functions. Okay. Also in multiplying, we looked at multiplying as well. So our homework today is 5.5 worksheet. I have that printed off for you. All right. Tomorrow we will finish this up. We will look at composite functions. That means we will compose the f and the g together.